All right, let's begin. This talk is about open source ColumnStore databases. In this talk, I will talk about MariaDB and ClickHouse, MariaDB ColumnStore and ClickHouse. So my name is Alex. I have been working with MySQL for probably too long. Since 2006, I joined the MySQL EB company behind MySQL. Worked at Sun Microsystems, Oracle through acquisition, Percona, and then recently I joined VirtualHealth. So VirtualHealth is a medical startup. We do medical records for insurance companies. So this talk will be more about my experience of how to create a reporting system based on open source ColumnStore databases. So again, this talk is not about the specific of implementations. There are a number of good talks at this conference about MariaDB ColumnStore implementation and ClickHouse implementation. This is more about how we can fix this specific problem. And specific problem is the queries, the reporting queries in MySQL are slow. So again, this is about what is the problem, why queries are slow in MySQL, and how we can solve that. So all examples are real-world examples based on the medical insurance records. We do the software as a service for medical companies. There will be no PII data. I have sanitized all the outputs. So let's look into this. So this is the query. And the query is pretty simple. Well, relatively simple, but it is slow. So what this query is doing, we want to know the top 10 clients who visited doctors most often. This is a typical report, right? And we run it in MySQL, and this is 46 seconds. Now, what exactly is slow? So is 47 seconds slow? What do you think? Who thinks that is fast? All right, Sveta thinks that this is fast. Okay. So I assume everyone else thinks that this is slow, including me. But that depends upon expectations. Let's see if this will work. So in the data science world, it's actually it is actually pretty fast. So my wife is a data scientist. So in her opinion, when she runs a query on Friday night and came back to work on Monday morning, if the query is still running and it's only 50% done, that is slow. Everything else is pretty fast. But at the same time, in our case, in the real-time report or dashboard, this is extremely slow. Anyone have that type of problems in real life? So you run the dashboard, the query there is slow, and this is pretty bad. So what happens when users are not satisfied with the load time? What they do? They do stop and reload. Stop and reload. So we ended up with MySQL running those queries because in many cases the applications are not reading well enough, so they're not killing the query. If we stop the page, it will not kill the query. So we end up with MySQL running in tons of queries, and they will probably never finish. So what do we do? Any ideas? If you have the 47 seconds query, what do you usually do? Any guesses? Right. how do we optimize that? Well, add an index, right? So that is number one. We need to add an index. Well, another idea is to create a report, a table per report. We can pre-generate the tables for each of our report and use that. Well, another idea is that we can pre-aggregate the data. So instead of using the raw tables, we can create a table per group of the report. And then the final report can use that table and aggregate it again. Or something else. So let's take a look. Use index. But this is already using an index. Our query that I have showed you using an index on client. Right, this is our index, the client ID. Well, maybe that is not enough. Maybe we'll need to create a covered index. So here I have created an index that covers all the fields that I'm retrieving. But it's still slow. It improved a little bit, but it's still 38 seconds. It's using temporary, it's using a file sort. That's because the query is doing order by and group by. This is normal. Now, I would, as a consultant, I would ask, how large is your table? And ended up that the table is not that large. This is interesting. This is less than 4 gigs on disk. However, we have 24 columns in this table, including things like notes, which is text, and description, which is also text. So we are talking about 10 million rows and 4 gigs on disk. So it's nothing, but MySQL query is still slow. So other options, right? We can create a table per each report. It will work, but there are too many tables, and it is hard to maintain. We can also pre-aggregate the table and group by client, do the average sum, group by date. So we will need to create a pretty good number of tables that we can potentially use in our reports. So the problems here are that some aggregates cannot be re-aggregated. Still too many tables, and it's pretty hard to maintain. Anyone in this room has been facing the same problems? Cool. All right, so let's see what we can do. Now, that was only the beginning. Now, this query. So this is much more complicated query. And the reason why it is complicated is that our schema is highly normalized, which is very typical in the online transaction processing systems. So what is here? We have a client visit. What client visit is someone visiting a doctor. That's a client visit. Now, during the visit, there can be a medical procedure. And this is client procedure table. So we need to draw in the client visit to client procedure table, right? Then what complicates this is that if we're looking for financial information, the money information, we will need to join the client claim table. A claim is basically the bill, the medical bill. But the thing is that to join the procedure to the bill, we need another table because it's many-to-many relationship. One medical procedure can have multiple bills associated with this. And one bill can also be associated with multiple medical procedures. So that's why we have 4 tables here. And any guesses how long this query will run in MySQL? 5 minutes. So this is 5 minutes query. This is definitely slow. So how do we optimize such queries? And by the way, I have left behind some of other complications, I would say, because we need to join some other tables, some dictionary information, and stuff like that. So in the real world, the query is even more complicated, and in the real world, we're talking about 10, 15 minutes. So why MySQL is slow for such queries? Any guesses? By design, I mean. All right, so first of all, it's row-oriented. So this client visit table, for example, we are only retrieving a couple of columns, a couple of fields. But we need to retrieve the whole row. In case of InnoDB, it's even more, because InnoDB organized data by pages. By default, it's 16K page. So if we're reading from disk, it will need to read more. And finally, MySQL will use one CPU core per query and not utilize all the queries. That is one of my major concerns usually in terms of MySQL, and major lack of feature, I would say, in a standard MySQL, where one query will only utilize one CPU core. In the modern hardware, in the model world, we may have 16 CPU cores, we may have 72 CPU cores, and MySQL will utilize them if we will hit MySQL with multiple queries at the same time, right? But for scaling up for a single query will not help us. So this is the great visualization by ClickHouse of how and why MySQL is, by design, is not optimal for that queries. So on this picture, the red bars represents fields. Those are the fields that we will need to retrieve. The yellow rows represents our table rows. Of course, we use indexes in MySQL. And in MySQL indexes will help to avoid scanning too much rows. However, for the reporting queries, we may end up scanning the whole table. This is normal. This is what happens on this picture, right? To retrieve these 3 fields, we will need to scan all the rows. Now, another possibility, another option, is to organize our data differently, what we call column-oriented database systems. In the column-oriented database systems, it looks like this. So instead of organizing the data row by row, we organize it by column. So we create a file per column. In this case, if we need to read only 2 fields out of 200, we can read only 2 files without retrieving all the rows from the table. So now I will talk about the ColumnStore databases, and I will focus on 2 of them, on MariaDB ColumnStore and Yandex ClickHouse. I will show what I have done for our medical history records and how we have optimized some of those queries. I will not talk about specifics of ColumnStore database and ClickHouse. There are very good presentations on the conference. One is MariaDB ColumnStore tips and tricks, today 5. And another one is by Jervin, low-cost transactional analytics with MySQL. This is about ClickHouse. And Alexey Milovidov will present tomorrow about ClickHouse features. So if you're interested in either MariaDB or ClickHouse and you want to know more about that, I would suggest visiting those presentations as well. So I have done a number of tests and created those AWS EC2 instances. Those have a number of pretty good number of memory and CPU cores. Finally, all my tests are actually done on box 1. I have used box 2 to see if I can increase the number of tables and joins, because that requires more memory. So the question is, the main question is it worth it? Do we want to move our database to MariaDB ClickHouse or Yandex, to MariaDB ColumnStore or Yandex ClickHouse? So I have done these tests, and this is our query number 1, a single table query. So again, in MySQL, the response time is 46 seconds. In ClickHouse, it is 0.7. MariaDB is 11 seconds. So we can see this substantial performance increase. ClickHouse, 600%, MariaDB ColumnStore, 400%. So this is definitely worth it for query number 1. Let's see query number 2 that joins 4 tables. So originally, 5 minutes, 18 seconds in MySQL, 33 seconds in ClickHouse, and 1 minute, 2 seconds in MariaDB ColumnStore. So now we're talking about 900% increase of, well, performance increase, right? And 500% performance increase. Yes?
On your previous slide, is there, it said 0.7 for ClickHouse, but that is more like 6,000%.
Yeah, probably missing the zeros here. Right, I will redo that. You're right. Yes, you're right. This is even more. All right, so we can see a significant performance increase in using the ColumnStore. Now, it also helps with decreasing the size on disk. Column-oriented databases use compression usually. And with the compression, we can see the substantial decrease of size on disk. So on average, we can see that the ClickHouse is almost 6 times smaller, and ColumnStore is 1.6 times smaller on disk. So that is also very good, because for the larger databases, we can store more. And because it's smaller on disk, we can also scan it faster. So now our goal is to export data from MySQL and load it into the column-oriented database so we can run our reports faster. So we have 3 options here. Option number 1 is to do ETL in the star schema, which is standard for data warehousing or OLAP. The second option will be to create ETL to do denormalized tables. Those options are good. However, they will require a substantial amount of work. We have lots of tables in our database right now, and then this is basically the next steps. What I wanted to do is I wanted to focus on a quick win without re-architecting the system. So the option number 3, and this is what I will talk about, is to copy or replicate data as is. So let's see if we can do this. So first, let's talk about the Yandex ClickHouse. Again, I will not talk about the implementation details, but Yandex ClickHouse is pretty easy to work with. It's like MySQL server. You just install it and use the ClickHouse client to connect to the server. So it's a client server. It supports replication, it supports sharding, but for these purposes, for the purposes of this presentation, I only focus on a single server. So for both MariaDB, ColumnStore, and ClickHouse, we will work on a single server. So how do I export the data from MySQL? We have this open source tool called ClickHouse MySQL, created by Altinity. And this tool will allow you to connect to MySQL. So the first thing I need to do is to export schema, right? So to export schema, I can use this command, specify the connection parameters to MySQL, specify the tables I want to export, and then I want to load it into the ClickHouse. One of the complications here is that we need to change the field types, and we also need to set our partitioning column and our order by column. The good news is that this ClickHouse MySQL tool will automatically do that. So it will translate and map MySQL MySQL field types to the ClickHouse. So it will also choose one of the fields to be the partitioning field and a set of fields for the order by. There are some bugs in it. Currently, enum is not supported. So what I had to do is I had to generate the schema for those tables and manually change some of them. So the next step will be to load the data. So there are two options here. The first option is to use the ClickHouse MySQL data reader, which turns out to be extremely slow. But it actually can retrieve the data and load it into ClickHouse. What I found the easiest and fastest is to use the ClickHouse native way of connecting to MySQL. So it have this MySQL function or table, right? So I can basically do insert select, and the select part will connect directly from directly to MySQL. So for 17 seconds, I have basically exported the whole table. So now what I want to do is I want to use the same application code to connect to ClickHouse. So in theory, I can go and ask the developers to change the driver and connect to ClickHouse using the connector, PHP or Python or something else. But at the same time, for some of the legacy applications, that may not be the good option. So what we can use is, the good news is that we can use the proxy SQL. We can use proxy SQL to connect to ClickHouse. So proxy SQL implements MySQL protocol. Because proxy SQL implements MySQL protocol, we can basically connect our application directly to proxy SQL, and then proxy SQL will translate that to the ClickHouse. This is how we can do that. We can install the proxy SQL and run proxy SQL with this option, ClickHouse server. Now what we will need to do is we will need to create users. By default, ClickHouse doesn't enable the user authentication, although it's possible. So in this case, we just need to create a user, a MySQL user, so we will be able to authenticate into proxy SQL, which pretends to be MySQL. So I just create a user account inside of the ClickHouse users table. Again, this is proxy SQL table. If you're not familiar with the proxy SQL, we are basically connecting to proxy SQL admin interface to manage the proxy SQL. And then after that, I can connect to the port, this port 6090, and I connect to this port to the host port with this new user, and now I can run my query. Unfortunately, this is experimental, and there are some bugs exist here. When I try to manipulate the date, it may end up with an error, lost connection to MySQL. Finally, when it will be more stable, I think it will be more viable option. So I was able to actually run the original query without dates, or if I convert dates to strings, I can still run it, but it looks like it doesn't support the native ClickHouse date type. Another thing about the ColumnStore databases is that I really want to join my original source. So in ClickHouse, I can do that natively. Another addition to my second query, the query that joins 4 tables, is I want to actually exclude inactive clients. And this information is only stored in the clients table. So what I want to do is I want to join the clients table directly from MySQL. So to do that, in ClickHouse, I can create a view, and this view will point to MySQL directly. So I can retrieve the data as if it is ClickHouse data, but it's really MySQL data. So now here I can join this to my original query, and I'm joining the view, client's MySQL view, and it will go to MySQL, retrieve this data, and basically exclude all the clients that I don't want to include in my report. So the next topic will be about MariaDB ColumnStore. MariaDB ColumnStore is a little bit more complicated. So that MariaDB ColumnStore architecture basically include 2 layers. If we don't talk about the data storage, it's 2 layers. The layer number from the bottom here, this layer is where the data is actually stored and manipulated. And then on top of that, there is the concept of so-called user module. That's an interface to the ColumnStore. This is actually MySQL MariaDB server. So because it's MySQL MariaDB server, you connect your application natively using MySQL protocol. And then MariaDB server will translate these requests and send it to the performance module, which will basically work with the ColumnStore database. Now, another interesting thing about this is that this is normal MySQL MariaDB server, so it supports the normal storage engines, the regional storage engines, InnoDB, for example. So you can mix and match. You can use the ColumnStore engine to basically send the requests here, or on each individual servers, here you can use InnoDB if needed. So let's take a look of how we can export data and load it into MariaDB ColumnStore. So my original thinking was excellent. We can just do MySQL dump no data and create a schema and just change the engine from InnoDB to ColumnStore. And then we can just load the whole thing. Unfortunately, it doesn't work out of the box. MariaDB ColumnStore doesn't support indexes. And our tables have indexes, foreign key constraints, and auto-increment primary keys. Neither of those will work. So we'll need to create a custom schema by basically removing all of this. There are some minor issues with the data types, but I was able to fix that. So finally, I have created a version of the schema, of MySQL schema, inside of the ColumnStore, MariaDB ColumnStore. So the next step is to export the data. The fastest way to export the data is to do a select into out file in CSV format, for example, and use CPI import. CPI import is a bulk import, so it will probably be the fastest way. However, I found that the most convenient way to load the data, and not the fastest, is to actually load the data into the MySQL server in InnoDB format. So basically, I do a dump and restore, no changes. It will end up with all tables as is in InnoDB inside of the MariaDB ColumnStore. So we have basically created a copy of our production system. And then what I can do is I can create my custom schema and just do insert into the ColumnStore table, select from InnoDB table. I can do it inside of the same database or a different database, it doesn't matter. And then finally, I can also join across the storage engines. So if I have small tables that I don't want to convert to ColumnStore, I can still do that. The downside of that approach is that InnoDB will, if you are using more complicated setup, I only used one server, and everything on that picture was on a single server. If I use a distributed system, that will not work very well. For my purposes, though, it was pretty good. So this is another example of how we can do joins between the storage engine. Again, I have exported the whole system. I have exported the whole production systems into MariaDB server. And for the largest tables, I have basically converted them to ColumnStore. So as you see here, similar way I'm doing it in Yandex ClickHouse. I'm joining to the original clients table, but here it is clients InnoDB table to exclude inactive users. So that will work as well. Finally, I want to talk about the replication from MySQL. It is both possible in ClickHouse and MariaDB ColumnStore. So for ClickHouse, we can use the ClickHouse MySQL tool to replicate. It's basically a binary log reader. You can connect the ClickHouse MySQL to your original MySQL server. In my case, I have connected it to Replica. This example is from the documentation page. The reason for that is, unfortunately, I was not able to do that. The reason for that is we have lots of traffic, and we also have lots of things like custom stored procedure and stuff like that and triggers. And it ended up that some of the events that has been generated in raw format was not 100% compatible with this. But it is possible. The column store, the replication from MySQL is coming soon. There has been 2 fixes that implements the replication from MySQL source. So we can easily copy the data into InnoDB format, right? That's not the case. That's not what we are looking for. We want to have the column store engine as our destination. So we want to have MySQL, normal MySQL server, replicate to our MariaDB column store, and then all the tables will be updated real time or close to real time. So this is coming up. What about update and delete? So this is the area where the column-oriented databases are usually the slowest. Some of the column-oriented databases simply doesn't support this. And for example, ClickHouse originally didn't support that. But currently, both MariaDB ColumnStore and ClickHouse support delete and update. So we can do a single row update, for example. One of the reasons that I didn't want to bring up the client table into the column store is because this is not static. If you think about this, client visits, client procedures, and medical bills are sort of append only. If I go to the doctor, they will generate the visit, will generate the procedure, they will generate the bill, so it will append or insert into our tables. But the client table can be changing. If I change address, for example, or if I become inactive, or if I lose my coverage, something like this, or if I change the job, then we will need to update the client table. However, we can still do that in both ClickHouse and MariaDB. So this is the example. I want to set isActive flag to 0. So in MariaDB, that's possible. That's not fast, but it's possible. It works. And in ClickHouse, it is implemented as a different, it's called mutations. So it's not update clause. So it's implemented as alt table update. This is implemented asynchronously. So when you run this update, it will be very fast. But behind the scenes, it will start rebuilding some of the partitions and some of the files to implement that. For my purposes, for our purposes, it will work. All right. Then finally, I want to talk about when you don't want to use the column store. Well, the first example, pretty obvious example, is things like a single row update or delete by primary key or retrieval. So in MySQL, in InnoDB, obviously, the data is organized by the primary key. So if I want to retrieve a single row, that is the fastest operation in InnoDB. This is not the case in column-oriented databases. First of all, in most cases, there are simply no indexes. So to do this, it will have to scan. In ClickHouse, if we will order by ID, then it will perform relatively fast. So we are talking about from like 0 seconds to 30 milliseconds to 20 milliseconds. That should be OK. But the second case is much more complicated. So this is the example where MySQL will be significantly faster than ColumnStore database. So this is the pretty frequent query. We want to see the latest claims for the specific type. So I want to retrieve the recent claim data for the office visit. In MySQL, it can be actually optimized by creating a covered index or combined index. So we can create an index on place service, receive date in this order. What will happen is that MySQL will start scanning the index because the receive date is indexed. It will be able to read it in the specific order, and it will stop, abort, after finding 10 rows. So in MySQL, it's index scan, it's 0 seconds. ColumnStore and ClickHouse, it is actually much more complicated operation. It will have to scan a lot of rows. Also, in ColumnStore, it will need to change. We'll need to change this variable max length for sort data. Otherwise, thank you. Otherwise, it will not work. So again, this is the example of the query in MySQL where I have created the specific index, and it is just using this index. It is not doing any sorts. This is where MySQL is the slowest. So finally, one of the ideas that we have been discussing is online snapshots. One of the things that we want to do is to give the BI people, BI team, the ability to see what is being changed day to day. Of course, we're doing backups, and we can restore any backup. We can restore the backup to any point in time, but it will take time. And we cannot afford to store that because on disk it is pretty large. So what if we use the ColumnStore database, like ClickHouse or MariaDB ColumnStore, as online snapshot database? What I mean by that is we can have multiple databases and store 30 days of data in each database, which will represent basically each day. So for each day, I store the whole database. Then, the BI team can go and say, oh, you know what, on, I don't know, May 1st, we had that billing claims upload, and it went wrong, or something like that. So this is just an idea that what we can do with the ColumnStore databases. Thank you. So let's do a quick summary. Advantages and disadvantages. ClickHouse, fastest queries, very efficient storage. Disadvantages. One of the things that I have been struggling with is amount of RAM needed for joins. ClickHouse is optimized for, I would not say it's optimized, but I found that the ClickHouse works best if we have a single table. So if we have a single table with many, many columns, it is the most efficient. When we start using joins, the joins worked very well, but when we start using joins, we quickly run out of memory because current implementation of the ClickHouse is that it will need to load the join tables into memory. Another disadvantage is the no native MySQL protocol. We can use the proxy SQL, but it is less convenient. And then also we will need to create a schema for each of our table with different data types and stuff like that. MariaDB ColumnStore, the advantages are native MySQL protocol. It's much easier to integrate. There is a native shared nothing cluster, which in theory can help us to store much more data. For our case, it was not the problem. We don't have that, thank you, we don't have that task. The disadvantage is slower queries and larger data on disk. So the conclusions, both ClickHouse and MariaDB can help optimize the reporting queries. Again, the reporting queries in MySQL are by design not optimal. MySQL is good for a lot of small queries, tiny queries, but lots of them. This is not the case for the reporting systems. Reporting systems usually have very complicated queries, and we want to utilize all the hardware resources. We can see 5 to 10x or sometimes 100x performance increase for some queries, from 5 minutes to 30 seconds in ClickHouse, for example. So this is pretty impressive. Both systems can also be used together with MySQL, so this is one of the requirements. We need to retrieve data, we need to refresh data, ideally close to real time. And we want to sync data quickly. Ideally, we want to replicate real time. And both systems currently support that or will support it. Yes?
Do you know of any integration with Postgres?
No, I never tried Postgres. And that's it. We're hiring MySQL DBA at VirtualHealth. If you're interested, please come to me. And that's it. Questions? Yes?
So we're talking about having duplicate data in another system, separate backups, all that stuff, right? This is not an integrated, it's not a layer within MySQL, this is a whole other role.
Right. Both of them are different servers, different layers. It's not inside of the same MySQL server, right? Correct. Yes?
So we talked about the real-time replications. What's the time lag between the master and the slave?
Right. So this is asynchronous replication. Yeah, we need to finish that quickly. It's asynchronous replication similar to MySQL master-slave replication. So the lag depends upon how long it will finish all these operations that's coming from MySQL, right? So it's hard to say. It depends upon the traffic. It can be minutes or it can be 0 seconds. I don't know. It depends upon your traffic.
Okay, so another question is that so ClickHouse and MariaDB ColumnStore don't support update the delete very well, right? So in your replications, so you talk about most of the tables are just manually inserted, right?
Right, right.
For the update delete part, you don't do it, or so what's your solution? For some people, you reply to
No, the updates, ColumnStore support updates, deletes. MariaDB ColumnStore, it will be just slower. ClickHouse supports it as a way of mutations.
Okay, so in that case, the replication, you have to do something special for the ClickHouse?
The tool should support that. Jervin, who was in this room, will talk about the replication today, later on. All right, we have to finish that. Thank you very much. If you have questions, come to me.